Today we're talking about positive exponents and the rules for positive exponents. And let's start with a review of what we learned about basic exponents and what they mean. So just a quick review. Whatever number you have that's the big number, that's your base, and then the number that's small and raised is your exponent. The exponent tells you how many times to multiply the base. And so for example, 2 to the third means multiply 2 3 times. So we learned that when you're going to increase your exponent, you end up multiplying by the base, and when you decrease your exponent, you divide by the base. But we also learned that dividing by the base is the same as multiplying by the reciprocal of the base. So this pattern helped us to figure out what happens with our base. So when we get down to 2 to the 0 power, we know that that's going to equal 1 because we have to divide 2 by 2 or multiply 2 times 1/2, which will give us 1. 3 to the first power, same thing. We have to divide by 3 to decrease our exponent by 1. Therefore, we end up with 1 as the answer to 3 to the 0 power. So that's why anything to the 0 power equals 1. Then when we got down to our negative exponents, we learned that 2 to the negative first is actually the reciprocal of 2. So 2 to the negative first is 1/2. And 2 to the negative second ends up being the reciprocal of 2 multiplied 2 times. 2 to the negative third ends up being our base, which is 2, the reciprocal of it being multiplied 3 times. And we see this pattern also for the base of 3. So we already learned the rule a to the 0 power equals 1, or x to the 0 power equals 1. You can think of it any way, but any number raised to the 0 power is always 1. So now we're going to learn some other rules. So we learned in our previous lesson that 2 to the third is 2 times 2 times 2 times 2. So what is x to the fourth? X times x times x times x, right? And then we played around with how to write out something like 2 to the third times 2 to the fourth. But we're going to take this to the next level today. So here we would write out 2 times 2 times 2 3 times, times 2 times 2 times 2 times 2 4 times to represent 2 to the third times 2 to the fourth. So what I'd like you to do is think about what that would equal, not multiplied all the way out, but what exponent you're going to have on your base of 2. What do you think? If this represents 3 2's and this represents 4 2's, what do you think is going to be, what exponent is going to represent all of those 2's? If you think it's 1, 2, 3, 4, 5, 6, 7, you are correct because there's 7 2's being multiplied together. So in the next example, we have 2 x's times 3 x's. So how many x's are being multiplied all together? If you think it's 1, 2, 3, 4, 5, you are correct. So this is actually x to the fifth. So try the next one, y to the third times y to the fourth. What do you think that equals? Basically, you're looking at how many y's you have all together being multiplied. 1, 2, 3, 4, 5, 6, 7. We have 7 y's altogether being multiplied, so it's y to the 7th. Because the exponent always tells you how many of your base you have being multiplied together. So basically, when you have the same base and you multiply the same base together, you count up how many of those bases you have all together, and that's your new exponent. So the shortcut to that is adding your exponents. So 3 plus 4 is 7 for this first problem. 2 plus 3 is 5 for the next problem. 3 plus 4 is 7 for the next problem. And the rule is written this way. A to the m times a to the n equals a to the m plus n. In other words, when you have the same bases, so they have to both be the same. And then, for example, in this rule we have A and A, and our examples above I had Y and Y, X and X, and 2 and 2. They have to be the same bases. So when the same bases are multiplied, we're going to keep that base and we're going to add the exponents, and that will tell us how many of those bases we have multiplied